Hello everyone, my name is James Pruitt. This is my 8th lecture on generating functions. Let me write down what we've done so far. Last time we proved that 1 over 1 minus 3x plus 2x squared, the multiplicative inverse of that is the multiplicative inverse of 1 minus 3x plus 2x squared is equal to 1 plus 3x plus 7x squared plus 15x cubed plus, we don't have to go that far, 31x to the fourth plus dot dot dot. Okay, and we've also already proven 1 over 1 minus x, the multiplicative inverse of 1 minus x is just equal to 1 plus x squared plus x cubed plus dot dot dot. And we did this a general form, the multiplicative inverse of 1 minus cx, where c is an arbitrary complex number, of course not equal to 0, is equal to 1 plus cx plus c squared x squared plus c cubed x cubed plus dot dot dot. And now I want to take that knowledge and I'll just show you. Let me just show you instead of trying to describe something. So I'm going to, from this general form, I can derive this 1 minus 2x. The multiplicative inverse of 1 minus 2x is equal to, 2 is a complex, I just substitute in for c, I get 1 plus 2x plus 2 squared x squared plus 2 cubed x cubed plus dot dot dot. Now, what I want to do is I want to look at this sum of fractions, and I'm going to look at 2 over 1 minus 2x minus 1 over 1 minus x. And we talked about how to add fractions. We just say that's 2 times 1 minus x from last time, or the time before last time, times minus plus or minus 1 times 1 minus 2x, if that was a plus and that's a minus, all over 1 minus x times 1 minus 2x. And so when we do all the manipulation, we get let's see, we got a 2 and then we got a minus a 1, so that's going to be 1, and then we got a negative x plus a negative a 2 times negative x plus a negative times negative 2x, so that's a positive 2x, and we got a minus 2x, so they cancel out. So we got 2 minus 1 and negative 2x plus 2x, so we get 1 here. So we go ahead, and I want to go ahead and multiply this out. So I get 1 minus, we got a negative x and a minus 2x minus 3x, and then the negative x times negative 2x is positive 2x squared. Which is the one we found this multiplicative inverse last time, and I just listed that up here. So we already know what that value is. So we already know, and my scrolling is not working. Let's see. Some reason. I have to come over here. Okay, we already know what that value is right there. We did that last time. Okay. So what we got here, so I'm going to write this down clearly. So 2 over 1 minus 2x plus negative 1 over 1 minus x is equal to 1 over 1 minus 3x plus 2x squared. So we're going to go ahead and look at this side right here. Look at the left-hand side. So we're going to say that 2 over 1 minus 2x, I'll go ahead and write minus 1 over 1 minus x, is equal to, and I'm going to go ahead and write this. We know what this is. This is just 2 times 1 over, let's erase that and I'll write this better. This is just 2 times 1 over 1 minus 2x, and we said that was, I'm going to write that 2 times, man, I'm getting sloppy here. That's just going to be 2 times, that's 1 plus 2x plus 2 squared x squared plus 2 cubed x cubed plus dot dot dot, and then we're going to subtract the multiplicative inverse of 1 minus 1x, and we calculate that's 1 plus x. My head's not working. It's in the morning time. I just woke up. Plus x squared plus x cubed plus dot dot dot. And when we do that, we get 2 times 1 minus 1, so we get 1. 2 times 2 is 2. It's going to be 2 squared minus 1 is 3 plus 3x. Then we're going to get 2 times 2 squared is 2 cubed, which is 8, minus 1 is plus 7x squared. And then we're going to get 2 times 2 cubed, which is 2 to the 4th, which is 16, minus 1 is 15, plus 15x cubed plus dot dot dot. And lo and behold, if we go back up here to the top, and that's what we proved by that other method, by the method I described earlier. And that was very difficult to prove this. It's a lot of multiplication, and we had to guess. So not only was it a difficult, a lot of multiplications, there's a lot of opportunity for mistakes, but we had to guess. And if we come down here, and that didn't take us no time at all. For this right here, for this computation right here, that didn't take us no time at all, and we didn't have to guess. There's no guessing here. This is right. So what we've, let me see what time it is. So what we got here is another method to compute multiplicative inverses by factoring. So we factored this denominator out. We can factor out this denominator, and we can use a partial fraction expansion, as we did in calculus, and I think they use it in Laplace transforms too, to compute these numerators. And so when we factor this, we can split it up using partial fraction expansion. We can figure out what these numerators are, and then if we know these simpler fractions, if we know the multiplicative inverses of these simpler denominators, then we can just do what we did right here, and it makes life a lot simpler. And that's one of the major ways we're going to attack this. We're going to do it that way instead of the previous way, but we still have that method I described earlier, but that involves guessing. So that's still a way to calculate multiplicative inverses, but this is an easier way. Okay, with that said, so I'm going to go back and look at that recurrence. I said we want to do generating functions to help us solve recurrence relations. So in particular, we looked at this one, a n minus 1 plus a n minus 2, with a0 is equal to 0, a1 is equal to 1. Let me see where we're sitting. Okay, so this recurrence relation is the solution of which is the Fibonacci sequence. What we want to do here, this is a relation amongst complex numbers, and we want to transform that into a relation amongst sequences. And that's what we've been developing, all this algebra we can do. We can manipulate sequences. So we did this that first lecture. We transformed this, and I'm not going to do that right now. We transformed this into this equation amongst sequences, where a is a generating function of a sequence that satisfies this recurrence relation. So a satisfies this recurrence relation. So we just have to figure out what a is. And the equation that we got was a is equal to x times a plus x squared times a plus x. So what we want to do is we want to solve an equation like we always do. Get the a's, the unknowns, which are the a's. These x's are not unknowns. So that's the tricky thing with generating functions. X's are not unknowns. These are known sequences. This is a known sequence. This is a known value. This is a sequence, right? With a0 equal to 0, a1 equal to 1, an equal to 0. This is a sequence of our elements. This is not we're not solving for x. We're solving for a. So we get the a's, the unknowns, which is a. This is the variable that ranges over our set of sequences. This is a known sequence. This is a known sequence. This is a known sequence. So it's a minus x a minus x squared a is equal to x. And then I can distribute out this a. So I got a times 1 minus x squared, and that's equal to x. So look at this right here, what we got so far. So let's see, make sure my time's sitting all right. So I have this sequence here, 1 minus x squared, and it has a non-zero constant term. So what does that say? That says it has a multiplicative inverse. So I can multiply both sides by the multiplicative inverse, and I get a is equal to x over 1 minus x squared. And I only can do that is because I have this non-constant term here. Listen to me, that's not non-constant term. The zero term that is constant. That's the only reason I can divide. If you have a zero term that's you have a constant term that's non-zero. I'm getting flustered. You have a constant term that's non-zero, then it has a multiplicative inverse. Then you can divide. So there we go. We've solved this. Now we have it. We solved this. This is a generating function. This is x. We know what that sequence is times the multiplicative inverse of 1 minus x squared. So we want to compute the multiplicative inverse of 1 minus x squared. And let's see what we're sitting on time. Okay, let's see if we have time. So now we know a. Now all we have to do is find the multiplicative inverse of 1 minus x squared. And we're going to go ahead and factor that like we did just previously. So we know from calculus, and I'm going to do something. I'm going to go ahead and write the factors. It's what is our negative b plus or minus the square root of b squared minus 4ac over 2a. I think that's the quadratic formula. I have to double check. So that's where you got ax squared plus bx plus c. Okay, so now we go ahead and see if I can compute those. So we got negative b. I'm going to pull that up and we're going to watch the time. Negative b is 1. Negative b is negative 1. So we got 1 plus or minus the square root of b squared, which is 1. 4ac. A is negative 1. And this is not going to. C is 1. So it's minus 4ac. Okay, I'm getting bogged down here. I'm going to stop this, and then I'll calculate it. Right, my brain's not working right now. Hold on one. I'll do this first on the next lecture. Okay, thanks. Bye.